Hello all, welcome to Ambari Cloud YouTube channel, part of Ambari Cloud LLM course. We will be talking about chunks and overlap. So we in the previous video, we already learned about page split. Basically, if you look at this is a big document and we're going to split into pages, right? And page 1, page 2, right? So all you need to do is just load the page or a document or a web page or JSON. Then after that you can split it. Then you will have a pages. Then page has a metadata and what is the page number and index of the page, and then the document the name. Yeah, so the file name, right? Then of course the page content, right? So it has the document has a metadata, which is the page 0, page 1, page 2, whatever, and then the file name. That is how we're going to. Once you complete your splitting of the document into pages, right? Next thing is we need to learn about how to going to split it. Okay, why we need to split it, right? So when the document is, if you look at these documents, right, some of these documents are very dense, a lot of, right, and you want to send too many of these pages to LLM, then you will get a token problem, right? LLM will not accept it. So that's the reason then we're gonna split the documents or pages into chunks, right? And chunk has certain characters and number of characters, let's say 500 characters, right? Then how you can come up this number of chunks, the number of characters for a chunk, right? So basically you read the page, right? Then calculate the token size of the page, right? And then, you can decide you're gonna chunk it, right? And how many characters you want. Once you chunk completes the chunks, then do you need to overlap it? We will talk about the overlap, okay? So the recursive character text splitter is a powerful, flexible text splitting tool in long chain, right? It's been used to provide creating the chunks and also preserving the semantic coherence. That means you can also add overlapping. So that means, let's say if you split it and my name is Satya Kondapalli and then the first chunk ends with Satya, right? And the second chunk start with Kondapalli, then you lost the connection. But if you do a overlapping, the last line or last two lines also will be restarted in the next chunk, right? That way, then these two chunks are kind of maintains some context relation, right? So that's why semantic coherence. So again, the split text into smaller chunks based on the hierarchy of delimiters such as paragraph, sentence, and words. And then, it's been ensure that chunks are semantically meaningful, improve the quality of applications, particularly embedding, and then allows you to do similarity search. And then these chunks cohesively together because they all belongs to one file page. So how do you chunk it? Then, you have a chunk size, the number of characters per chunk, and the overlap between chunks. So the net chunk size is chunk size minus overlap, that is the net chunk size. Okay. So if you look at here, a PDF document, you have a chunks, but they're all, kind of a overlapping. That way they know each other. They all belongs side by side chunks, right? If you don't have overlap, there are independent chunks. Yes, they are stored nearby in the vector store, but still they lost the connection. So if you do overlapping, it's always nice to do some overlapping, particularly when you do chunks, and then they will maintain the relation, right? So I did this image from ChatGPT. Basically, if you look at it, these chunks are overlapping. That way, they have a connection between. This basically is maintaining parent and child kind of, not real, right? Parent and child of relationship. Okay, we'll look at how it works. And then because of the overlap, it maintains the context, right? And there are, particularly when you do summarization, then questions and answers, right? then all the related, when you ask for, okay, let's say I have invoice number, ask for some information, but invoice number is in one chunk and then amount is in another chunk. But if the invoice number is carry over between these two chunks, then you see, I will get a better results and less hallucination. Okay. When to use, of course, large text documents, right? Whenever you split large text document, right? And that means more dense. And definitely big documents, you're going to split into pages, but then page also need to be chunked if it is a document is, very big. Okay. Then token limits, right? Depends on your LLM. LLM controls the token limits, right? You can't tell the entire 100 pages book to the LLM and ask to do things, right? No, LLM will not able to do. And then if you want to increase the token limit, you have to pay more. Right? So that's why we have to do chunks, and then we keep sending these chunks, and then finally you will get a better results and within your cost, right? Okay. So how do you do that? Right? You're going to use a recursive character text splitter from long chain. Then you have a text, right? Or any text, right? Then or maybe file. Then you have a document. Document has a page content, right? Then you're gonna create a splitter object. Then you have a chunk size. What is the maximum size of the chunk? And then you have overlap. That means 10 characters from this chunk is overlapped. And so actual characters are 40 here. And then if you have any other, schema information, separators and all the things you can define. Then you're going to create, from these chunks, then, you're going to, do chunks, right? Then after that, you can see so here, this text document, I'm going to create a document, right? I'm going to create a document. We always need a document object. Then once the document object, then we are going to apply the checks, right? So, so if you look at here, then you can use the length function to read the size of the chunk, and then automatically it will try to do better. Then, right, as I mentioned that in the previous video and current video, whenever before you split, find out what is our page size in terms of tokens, right? So you can use the token method, right? Then you're using some model, then you will get the encoding object. Then you can calculate your page and tokens. Then you can also calculate each chunk token, but chunk size is not same as token. Remember that. Okay, it's encoding, right? So then you can, play around, the tokens are, not properly distributed tokens basically your chunks are within the range of your token size. Then it not exceeding, it will not get any errors with your LLM. Okay. So it's a simple method here, and then you pass the text, and then, you get the token size. And then you can display here, right? Okay, let's look at the example here. So I have a methods here. So the library, I'm going to read my one document, read and split, then one page. Then here, I'm going to build the split object, right? And then if you look at here, I'm using 500 and 100 and start index here. So let's create a split object. Then I'm going to split my page, right? So here, then this is my pages, right? This is my text splitter, then pages. Okay, split the document method, then pass my pages. Then it's going to split. Now let's run that one split, right? So here, the original page split into two documents. Original is also each page one. There I have only one page here. Right? So one page is also document. Let's put that one here. Okay, run. So this is a document object, but I'm going to do a split on it. So now I have two documents. First document meets 500, then whatever, right? Then the second document, all the stuff. Now let's change this one to 300. Now I have three documents here. Now let's change to 200. Then I have 1, 2, 3, 4, 5 documents, right? So that means I have 5 chunks. Now look at the overlap here. Now, if you look at the page content, Now let's go to one more here. That's nicely. Okay. So if you look at here, page 1, page content, or chunk 0, and next chunk page content. Now look at here, right? Tax ID, number, whatever the less, right? Now phone number, right? Now if you look at here, the email ID is from here, email ID. This is repeated here up to here, repeated here, because I have a 100 cat. Let's change to 500. Okay. Now, since the repetition is less, then look at number of chunks change. Right. Now let's run here. Okay. Now only from the tag, previously from email started, right? Now only from tax ID it is repeated. So now if you look at here, these chunks belongs to one page, right? How do we know these belongs to one page? Okay, look at the metadata. Okay, and look at the metadata. Okay, so both belongs to the same file, right? And then same page, and it has some index number, right? So it belongs to the same page. So that way they're all, and then these chunks, right? Then now when you store, right, and there's a context maintained, right, and then there are the embedding. When you do these embeddings, and you are almost storing in the same space because they're almost nearby. If you look at most of the data is nearby, most of the data. So when you search on it, okay, give me the tax ID number 994, then you will get both of these. You will get both of these things. Okay. Now here I'm going to do loader. Okay. So page content, right? Then just page wise. Then I'm going to split it, and then I have a 66 splits. Then if you look at here, right, then the data is there's the splits and then chunks on it, right? Okay. And now let's look at I have a method, right? Tick token, and then I'm going to tokenizer. Let's run the tokenizer. So I created a method. Then, so for this method, if I pass this text, how many tokens it is going to get? So it's going to, so when I send this information to LLM will consume 28 tokens. That means your account will consume 28 tokens. Okay. Now let's go here on the, right? And then this is our split 11, right? And if you look at the source and then page content, and this is a 1, right? Now let's one more, and of course metadata, this one. Then what is my metadata, right? Tokens. Sorry. What is my 11th page content, right? Page content tokens here, right? And what is my token contents of page 0? Let's do the page 0 here. So it depends on your content. Look at this one, right? This is the content. This is a 206. So going back, after you load, after you split into pages, then you can also send your entire page content before it's split, right? And let's say, for example, here we didn't split it. You can take this entire page. Okay, let's take this entire page. Okay, and I'm going to put the entire page here. Okay. 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 It has 347 tokens, right? So now we have, how do you split it based on this? This is a small page. So look for the steps, right? Load, split into pages, split into chunks. While you are splitting into chunks, look for what is the overlap you are looking at. Then build this method, right? Token size method. Then find out each page tokens. After split, find out each chunk size and then adjust the chunk size and overlaps and all that stuff. From the chunks and overlapping is not a perfect science. You can play around, but always don't do too small chunks. Then it will occupy too much on your vector store. Don't do too big chunks. Then you will page have one big chunk and one small tiny chunk, right? So try to do equal distribution of chunks of a page, right? Of course, some pages are half, some pages are full, depends on your document, right? And we see some empty documents and half-page documents half-page pages within the document. But it cannot be perfect, but it cannot be doing for each page different. For each page, don't do a separate chunk size for each page. Do it for one document, but then at least try to get a page size, and based on the design, your chunk size and overlap. So as of now, we learned about how to read, how to load documents, and how to do a page split, then how to do a chunks and overlap, and then also how to do a token size, right? So learn this, and then next we will go to embedding. So let's go to here. After that, then one more example. Same thing here. You overlap size and you split, and nothing much difference here in what we shown in this Jupyter notebook. And once we're done, we will get into embedding. So embedding is basically converting your raw text or chunks and documents into numbers, dimensionality, right? So we will, we'll convert into matrix format, right? Then we look at in the matrix format how the data has been converted and how this data is stored in a vector store in an n-dimensional arrays. And then when you query, when your text is also converted into embedding, and then these embeddings are compared to existing embeddings in the vector store, n-dimensional space, and then find the nearest neighbors and then similarity search, then you will get the documents back when you are. So we submit a text, convert into embedding, and compares with the existing embeddings, and then you will get the documents back. And once you got the documents, and then you send it to LLM as augmentation, then the LLM will decide your answer for based on your question. Okay. So we will look at in the embedding in the next video. Thank you. Any questions, reach out to me, skondapalli@ambaricloud.com. Thank you. Bye now.